Hi guys, your friendly Captain Orbit here. Just as promised, I told you I would show you how we calculate our speeds for takeoff and also the cleanup, and thereafterwards continuing to climb to our cruise altitude. So I've got here my iPad, which is also the electronic flight bag in here. It's a company issued iPad and it has all the apps that we need in there. So as I said, the OPT, I'm going to select that now, OPT, and it comes up to that page. On that page, it gives us the version number. As you can see there, it's got a version number, and all the crew generally check the version number to make sure that we are all operating on the same version number and have updated our systems. If it's not updated at dispatch, we do the update immediately. It takes a few seconds and it's updated. So that's one of the checks we make before dispatch. So all this stuff I'm showing you, we do while the aircraft is being loaded on a cargo aircraft, on a passenger aircraft. While this is going on, passengers are boarding, getting comfortable in their seats, changing seats if they're empty seats, that kind of stuff while we're doing this. That's what's going on. Okay guys, so this is my iPad and I've got the Boeing OPT, which I'll select now. There. Onboard performance tool. Comes up, as I said before, with a version number at the top there. So we check that before we do our calculations. So I'll select that. Version number is okay. Then it comes up with a list of the aircraft that are available for us to use on this onboard performance tool. Now this information is entered by the performance engineering side that deals with this, and they insert all this data that we would be using depending on which aircraft we were flying. So let's assume today I'm flying the 747-8, so I'll select that. And then it brings up, as I told you before, the list of all the aircraft -8s that we have in Cathay Pacific, for example. So I'll choose any of them, LJD, and it comes up to this page, performance for takeoff, which is what we want because we want to calculate the takeoff speed. So the first thing I'm going to do is verify that, and then the information I'm going to put in here, obviously, I'm going to select the airport. There, it opens up that, and VH, which is Hong Kong, let's say Hong Kong VH, and it's already come up there because it's not VHHH. It's probably the only airport with a VHH that we actually fly to. There are several others that start with VH, but Hong Kong is the only one that's in the database, so it probably populates it straight away. Then I choose the runways, selecting there. Runways, it brings up a whole list of all the runways available for us to use at Hong Kong International Airport. And let's assume then we're going to use 7 right for takeoff. 7 right, am I going to use the full length or am I going to take off on an intersection? So if I was taking off on an intersection, then ask me which intersection, Juliet 2, Juliet 3, or Kilo 2 intersection for takeoff. So let's assume today we're going to use the full length because we're fairly heavy. So I've selected full length there. Next thing is the wind. Now the wind can be inserted either as a head or tailwind, or I can put in the actual wind. So I'll put in the wind. Let's say off 7 right, we've got 115 at 15 knots. There it is, 115 at 15. It's then going to, if I say done, it then gives me, with that wind, it says you'll have 11 knots of headwind and 11 knots of crosswind component with a wind of 115 at 15 knots taking off at runway 07 right. So it works out that by itself. If I wanted to be conservative, instead of saying 11 knots of headwind, I could force it and put 10 knots of headwind. I could just put headwind 10, H10. But in this case, I put the actual wind in and it gives me the best available wind for those conditions. Outside air temperature, again, we get from the ATIS, either digital or what we write down. So let's assume the temperature is 23, which it is, I think, today, and then done. And it works out the temperature and it gives it to me in Fahrenheit if I wanted to. QNH, airfield level pressure, let's say it's 101 say. Done. And so now I've got all the data in there for calculating my takeoff weight. So what happens is, as pilot flying, I'll say to the pilot monitoring, okay, are you ready to enter the data for takeoff? And then I announce exactly what data I'll be using. I'll say I'll be using, the aircraft is Bravo Lima Juliet Delta at Hong Kong 07 right, full length, condition dry. I missed that one out. Condition, let's put that dry. It's got several conditions just to show you there. It's got wet, standing water, slush, compact snow, dry snow, and so on. So it's a dry day today, so dry. So I'll say to the PM, dry, wind of 115.15, temperature 23, and the QNH of 1018. The PM will verify and say, check, that's the data I've entered as well. And then we'll say, optimum flap. Optimum means we'll let this system choose for us the best flap setting for the conditions we're putting in. Thrust setting rather, and then flap setting the same thing, or again the system based on the data we put in and the takeoff weight, which is coming later, it will give us the best flap setting. We only have 2 flap settings for takeoff on the 747, flap 10 and flaps 20. Packs generally are on. We can take off packs off if we need to get a little bit of extra thrust at hot and high airfields, for example. It was a common thing. We used to take off packs off, for example, in Johannesburg when I flew the 747 passenger version. Sometimes we needed the extra weight and we'd take off with the packs off to give us that extra thrust just to get off the ground, because Johannesburg is about 5,500 feet above sea level or thereabouts. Anti-ice, if it's cold and so on and we need anti-ice, we'll select it there. It could be engine, or it could be engine plus wing anti-ice. Now the wing anti-ice actually doesn't work on the ground, but immediately you lift off and the squat switches make on the landing gear, the wing anti-ice valves would immediately be available to operate. But they're absolutely useless. The wing anti-ice rather is not useful at all if the leading edge devices are extended, because you're just trying to anti-ice the world, as it were. Anyway, so we won't be using anti-ice today. It's off. And let's assume the takeoff weight, which we get from the load sheet, which would have come through onto our iPads. Let's say it's 410,000 kilograms, 410 tons. Done. And it will populate it as 410,000. Center of gravity, again from the load sheet, depending on how the loading was done in a passenger aircraft, where the cargo was loaded and the forward load, which section has more passengers and so on. It's all to balance the aircraft, as it were. Okay, so let's say it's 25%. 25. So now I've got everything in there. Having announced all this to the PM, I say to him, optimum, packs on, anti-ice off, takeoff weight 410,000 kilograms, CG 25%. And he says, that checks. Then we hit the button here that says calculate. So I'll hit that there. It's calculating, takes a few seconds. And it comes up now with the speeds for takeoff on the bottom there. Then I announced to the PM, okay, I've got flaps 10, runway 07 right, full length. Takeoff gross weight, we verify again, 410,000. The load sheet will be in front of us at the same time, so we can verify it as a last minute. Engine out acceleration, 1,400 feet. Now that's specific to Hong Kong, runway 07 right and 7 left. The standard acceleration altitude for the 747 we use is 1,000 feet, but it varies depending on the airport. But the standard is 1,000 feet above sea level. And we're going to, it says you need derated takeoff 1, and the thrust setting is going to be 92.8 N1. Assumed temperature of 38 degrees. So even at 410,000 kilograms there, we're taking off at TO1, not even TO max, TO1, and it still gives us a derate up to 38 degrees. And then I read out V1 160, VR 176, V2 187, and VREF 30 174. That is a verification we do as part of the final preparation when we insert the speeds for takeoff. So that's how we calculate the takeoff speeds. We use this on the onboard performance tool. If during the start we push back, there's a runway change, and they tell us, oh, runway change in progress, runway 25, then we have to do an entire calculation again. I'd have to come back here and change the runway from, say, 7 right to 25, from 7 right to 25, let's say, 25 center, let's say. There you go, 25 center, dry, wind. I'd have to put in the new wind, would get the new ATIS, put the new wind in, put the new temperature, QNH. There's no change there. This would be the same, this would be the same. And then I would hit calculate again, and it would, again, take a few seconds, bring back the speeds. So let's say nothing changes in everything here. And in this case, we're taking off with the tailwind. If I leave the wind as it is, calculate. So now, with that, it says, well, in that case, you need D-rate, it's still D-rate, flaps 20 this time, because now it's a tailwind, 25 center, 410 tons, acceleration altitude going in the other direction is only 1,000 feet, not 1,400, and DTO1, 93.6, a lot more thrust, assumed temperature, 3-degree change of 35 degrees, and V1 is much lower now, 145, 163, 172, and VREF 30 is still 174. So that would be the new speeds. We'd have to reinsert this and then run the checklist again. So that's the performance data that we have just worked out for our departure later. So those are the speeds we're going to be taking off with, and the PM confirms that's what he or she got as well, and we're ready to go, and then we're ready to insert that data into the FMS, which will come up on the PFD for takeoff. So that's how we calculate the speeds later.